a new feature in browsers that's currently supported in Chrome, Safari, and Firefox. And there's partial support in Internet Explorer. No, we don't boo browser vendors. We want to support them all and make them all awesome. So the goal of content security policy is to help mitigate cross-site scripting vulnerabilities. If you've built a large website and had mean people come to your site and try to hack it, you will be familiar with this problem. The general approach for content security policy is a bit different from other techniques for stopping cross-site scripting. So most previous techniques either focused on server-side frameworks or on JavaScript escaping techniques. So content security policy is a bit different. In this model, what happens is the website declares to the browser a policy for where its scripts and other resources are expected to come from. And if the website loads resources or scripts from somewhere else, the browser blocks it. So the idea is if the attacker tries to load his script, his script won't be on the website's policy, and the browser will stop it, and there'll be no attack. So in that sense, it's a whitelisting-based approach, where you whitelist the scripts and content that you know to be good in the world. And then things that aren't on your whitelist hopefully won't be running. And things that are on your whitelist will hopefully not hack you. It's meant to be a defense in depth technique. So you shouldn't rely on content security policy as your only line of defense. You should do everything you're doing today to protect against cross-site scripting, input sanitization, output escaping, all that kind of stuff. This is just another layer to help you secure your website more. So as for availability, 1.0, Content Security 1.0 is available today. It's in most major browsers. As I said, the support in Internet Explorer is partial, and we're hoping in Internet Explorer 11 that they'll complete their implementation. There's a 1.1 version, which I'll talk about a little bit at the end of the talk, and that's under active development right now. And so we're adding some features and refining some things. And if you have feedback about content security policy or things you'd think we could do better or change, that's great to do as part of the 1.1 effort to do the next generation of this stuff. So I wanted to first start with an example of a policy just to give you a feel for what this kind of stuff looks like. So the policy is delivered in an HTTP header. So the browser requests your website, you send back the HTML, then in a header, along with your HTML, you supply the policy. So the reason the policy is supplied in the header is because that's hard for an attacker to forge. It's sort of a good trusted communication channel to communicate the policy from the server to the client. And then you can see that the policy here is a sequence of directives. So there's a default source directive, which is that's the default. So here it says self, which means by default, allow me to load resources from my own origin, from my own website. And then for different types of resources, you can be more specific or override the default policy. So here in this policy for images, I've said the source is star, which means anything goes. And I've written this because images, if I load a malicious image into my page, it's not the end of the world. Life is not going to end. It's probably going to be, not ideal. It could be like an ugly picture that I don't like, but it's not going to steal my user's data. Here, object, this is like the object tag or the embed tag that you use to load plugins. So here I've said that I can get it from these two different media hosts or from this CDN. And then scripts, I've limited it to just this trustedscripts.com domain. And so no other scripts can load in my page except if they come from this site. Does that kind of make sense at a high level? Yeah, good. Yeah. Yes, you can actually specify a directory and then it'll say only from that directory. You can also specify a scheme or a port or that kind of stuff. If you leave off the scheme, it sort of picks a good one. So if you're over SSL or HTTPS, it only allows HTTPS. If you're over HTTP, it'll allow HTTP or HTTPS. But you can always qualify it to be more specific if you want. So generally, the different SRC directives correspond to different HTML tags. The correspondence isn't perfectly one-to-one. So the object source means the object tag. It also counts the embed tag because the embed tag and the object tag are very similar. So this is really about plugins. Plugins can come from these sources. And like image isn't just the image tag, it also includes like images that you load in your CSS. Basically, generally it's mostly images, but also other, yeah. That's a good question. So, oh, sorry, the question is, how are all these rules processed? Is it the like most permissive one works? Is it the last one that the browser sees? So within a given policy, the default sets up the default, and then the more specific directives override the default. But you can also, if you are having fun, you could send many, many policies. So like you could have 6 headers and have 6 policies. And then something is allowed only if it's allowed by all the policies. So it's a way of tightening things down. Because this is a security feature, generally we err on the side of defaulting towards security. So if you're sending multiple policies, maybe your server is making a mistake or something, and so we don't want to, or maybe one of the policies is coming from the attacker, or like something weird is going on. So we're conservative, and we say, well, they all have to pass all the policies. Does that answer your question?
Yes.
Okay. So these, I mentioned you can control different types of resources. These are all the different kinds of resources that you can control. I don't know why I put a big picture of Yoda here. Oh, I think I was thinking about like use the source, but that doesn't really make a lot of sense. Anyway, I wanted to focus on script source for a moment because that's the like key directive. If you want to block cross-site scripting, it's really about scripting. The other stuff is sort of allows you to fine-tune if you're into the details. So yeah, the script source directive, controlling the source of script, is really the key to blocking cross-site scripting. If you think about it, cross-site scripting is really about executing the attacker's script. There are other sort of variations of it, other ways of thinking about it, but in the end, what makes a cross-site scripting attack an attack is that the attacker is executing his script in your page and causing your page to do things it doesn't want to do, potentially leaking information or showing things to the user that they shouldn't see or things like that. And so the script source directive lets you whitelist scripts. So list out exactly where the scripts can come from that are allowed to execute, and no other scripts are allowed to execute. And so the idea is you will say, I want to get scripts from my source. Maybe you like to use the Ajax APIs that Google hosts for jQuery or something, and maybe you have a CDN, but that's it. So like, for example, you're probably not going to put the attacker's website on your list. I mean, you could. Yeah.
So it's space delimited?
Yes, they're space delimited. Yeah, the directives are delimited by semicolons, but the individual values for a given directive are just space delimited. Yeah. Yeah, picking the syntax was a little bit hairy because you wanted to like fit well in an HTTP header, and you also wanted to like fit well in like HTML attributes, so we were a little bit shy on like punctuation. Yeah.
So is this one of the first things you put in your header?
Yeah. I mean, it depends how worried you are about the attacker injecting different headers. Generally, I don't worry about that too much, so it's not super important like what order you send your headers or where in the header you put these things. Because generally I would take the view that the headers are going to get delivered fine. Most of your injection vulnerabilities are going to be in your HTML or in the body of your response.
You can put that after all your scripts stuff.
Well, generally HTTP headers get sent first before like HTML tags. So if you actually load your scripts, that comes in the body of your response. And so that comes after these directives. Yeah. It is possible, by the way, you don't have to supply it in a header. You can supply it in a meta tag, but that's not as secure because you could mess up before you put the meta tag. Yeah. I don't recommend using IP addresses, but you can. I mean, it's fine. You can also mix star and IP addresses, which will do weird things, but we support it. Why not? Yeah. So like, you saw earlier that we could have like image source star, which said give me images from anywhere. Well, we let you say script source star, but you might not want to do that. That's probably a bad idea because that says I'll take scripts from anywhere. It kind of defeats the point. Yeah. Yeah. So I would say that our general philosophy on this topic is something we call the priority of constituencies. So that means as a browser vendor, different people have competing interests. And the question is, how do we balance those competing interests? So like one person who has a competing interest is the person who develops the browser. So people who make browsers. And so we're pretty low on the priority of constituencies. Somebody like the author, so the person who makes the website or the person who supplies the policy is pretty high in that priority. But even above the author is the user who's actually using the browser. So they have the highest priority of constituency. So generally, if a user wants to modify how a website works, as a sort of philosophical point of view, because the user has a higher priority of it as a constituent, we view that they should be allowed to do that. So this doesn't prevent users from modifying scripts that websites supply. That was sort of a long-winded answer to your question. Yeah, and related to that, so users also have extensions in their browser. So we try really hard to make it so that the website's policy doesn't interfere with extensions. We don't always succeed, and if you read people who've given us feedback about content security policy in the past, people have written blog posts and such, you'll see that they were sad that they deployed a CSP on their website, and then people's extensions broke. And so we tried harder, and now we're better at having CSP not interfere with extensions. There was a question, yeah.
So can you write your extension if you know about this so that it can still override it?
You can, although our goal is that it works automatically, that the extension author doesn't have to worry about it. So for example, we automatically whitelist resources loaded from extensions. We allow those because we believe that they reflect the user's intent. These are good questions. I'm very excited about these questions. Yeah?
Does the meta tag override the header?
No, if you have a header, the meta tag is ignored. And if you have a meta tag, the first one is taken and then the rest are just ignored. So yeah. The meta tag is really for cases where you can't use the header, like in a file or something. So what happens when say you try to run a script that isn't listed in the policy? So the browser refuses. It says, I refuse to load this script from evil.com because it violates the directive that said only load scripts from self and from like APIs or whatever. There's also an event that gets generated in the DOM, so you can listen for that event if you want to see. And then there's also a reporting mechanism that reports back to the server that I'll explain later. Why did I put this here? Oh, yes, I remember. So, okay, so this is a script that comes from a URL, right? So it's like super clear what the source of this script is. It's from my own website. I decided to use Angular. If I put self in my policy, it's clear that this script should execute. Everyone's on board with that. What about this script? Where did this script come from?
HTML source, no origin.
Yeah, so you said HTML source, you said no origin.
Self.
From what?
Self, presumably. No, client.
Yeah, so these are all sort of good questions. So do you think that we should include this in self? Do you think that's a good idea? So what? No, why not?
As you said before, the reason you have things in the header is because that comes through pretty clean. The browser, that's reliable.
Yep.
But now somebody could screw with your HTML and inject script into the HTML, so you won't allow that to execute.
Yeah, exactly. Did everyone hear what he said, or would you like me to repeat it? Oh, I'll repeat it. So what he said is if you recall earlier, I said that we sent the policy in the header because we had high confidence that that data was really coming from the server and reflected the server's intent. But once we're down here in the body of the document, things are a little bit more murky. If there's an attack going on and the attacker is able to inject stuff into my page, maybe he's injected this. So maybe this reflects the attacker's intent and not the server's intent. And so if we whitelisted, if the server said self, I want to execute scripts that come from me, and then we get this, we don't know whether it really comes from the server or maybe is coming from an attacker who's injecting it. Does that make sense? Yes, good. Oh, did someone have a question?
You can't have inline script either?
Yes. So you can, so there's a separate token.
Sorry, I didn't read.
Oh, I tricked you because I put it on the slide after you asked your question. Yeah, so there's a separate token which says inline, which means allows scripts that are inline. But you might notice that we put the word unsafe here in the front. And that's meant to be a hint to you as the developer that maybe this is not the most secure thing to do.
So is that a technical keyword? The unsafe inline?
Yeah, so these things that come in quote marks are keywords. So as distinguished from things that aren't quoted, which are like, host names. So one of the things that we notice is that not a lot, but a sizable fraction of extensions had cross-site scripting vulnerabilities in them. And those are sort of pretty nasty vulnerabilities because if you can cross-site script into the extensions context, then you can do all the things that the extension can do, which is sort of a lot. So what we did is we actually revved the extension system. We went to version 2 of the extension system, and we cleaned up a little odds and ends, but the main difference between version 1 of Chrome extensions and version 2 of Chrome extensions is that in version 2, we actually enforce a content security policy by default. And in particular, we enforce one. It's a little bit long because it has a bunch of details in it, but it doesn't allow cross-site scripting. And then since we've done that, the incidence of cross-site scripting in version 2 extensions is it's not 0, that's still possible, but close to 0. Yeah, so generally, I would recommend that I'm not a performance expert, so please take performance recommendations I give you with a grain of salt. But I think it makes sense to combine your scripts, but you would have to do it as an out-of-line script, not an inline script. That's actually what most people do when they do this stuff. Yeah.
So how does it deal with on mouse over?
Haha, you guys are a great audience. So give me 2 slides. Okay, well give me 2 slides. I'll get there. Anyway, so this was my slide in case nobody got could this be from the attacker? So this is supposed to be like PHP, where you're just echoing the user's name into an HTML context. And I really enjoy this XKCD comic about little Bobby tables. So if you have little Bobby script tag or something, you could be in for a bad time. I think everybody should print out this comic and tape it to their monitor or something to remind them of this. Yeah. So what do you have to do? So really, what's going on is you're separating your code and your data. So if you hang out in security circles, you'll find that people repeat various phrases over and over again, like principle of least privilege or separation of code and data as general high-level security principles. And so really, that's what's going on here. By moving your inline script out of line, you're separating your code, which is the script, from your data, which is your DOM or your HTML.
Didn't answer my question.
Okay, one more slide. Oh, and you should do it async, or there's ways of loading scripts fast. Okay, this is your question, right?
Good enough.
Yeah. Okay. So what about these kinds of things? So these are inline event handlers. So you can have a button and you can say onClick and you can write some code here. And this has the same problem as a inline script block in the sense that an attacker could be writing this code because it's part of the body of your document. So inline event handlers also count as inline script, and you have to remove them to use content security policy. So generally, frameworks help you do this. So for example, this is how you might do this in jQuery. You would instead give the button a class, you would select it, and you'd bind a click handler, or listen for the click event.
Or an ID or a name or...
Yeah, any kind of selector you want. Yeah, so the idea is that this is part of your script, and this is your data, and they're separate. And the concerns have been separated.
So it's postload binding.
Postload binding. So jQuery does a nice job of this. I think other frameworks do as well. My slides happen to be jQuery based. So what's cool about jQuery is you can actually bind these events before the elements exist. So that's what this live keyword means instead of bind. So you set up the query and it says, later on, if someone happens to create a button in the future that happens to have this class, and somebody happens to click on it, please call this function. And so generally you can build an event map and then have the DOM come and go and not have to worry about actually finding the nodes and poking at them. Other frameworks that are more modern than jQuery have like even fancier ways of doing this. I think it's generally considered a good practice these days to like not use inline event handlers, but to use some more structured representation, like a class or an ID, and a more structured event map. You might disagree, that's sort of a matter of opinion. But
It's less obvious.
But yeah, this too is also in the sort of issue of separating code and data. Generally, people who've deployed CSP and work with this stuff, this hasn't been a big sticking point for them. This part has been pretty easy. Removing all the inline script has been more of a sticking point. And I'll talk a little bit about how we're hoping to help that in the future. So eval is also a way that you can get cross-site scripted. If you have an untrusted string and you pass it to eval, now you could be running the attacker's code. So set timeout also has the same problem. If you pass a string to set timeout, it gets evaled, essentially. But so instead of doing that, you should just pass a function. And that doesn't get evaled, it just gets called as a normal function. That's a very easy change to make. Anyway, so the eval thing is optional. It's disabled by default if you are controlling scripts. So if you have a script directive, but you can turn it back on with unsafe eval. I would say that unsafe inline is more unsafe. Unsafe eval is not such a big deal if you wanted to keep using eval in your code. But I mean, keep in mind that it is a vector where you could get cross-site scripted. Yeah, so here's my 4-step program to mitigating cross-site scripting. Move your scripts out of line. Get rid of your inline event handlers. If you're feeling ambitious, get rid of eval. If you're not feeling ambitious, you can skip that step. And then add a script source directive to your content security policy. Easy, right? We should all, no, maybe it's a little bit of work. So you saw earlier there's a big long list of directives. If you were feeling paranoid and you wanted to control more than just script, there are lots of knobs you can turn to have more control. So there's a short section in my talk where I tell you how to do that if you're feeling ambitious. So the default source directive is the one that helps you there. So you could have set default source to none, and now you'd have a very secure website that would not have very many features. And you probably wouldn't want to use it. But you can start with something more sensible, like by default load things for myself, and then refine it over time as you find that you have resources that are blocked. So here's a policy from a real site. This is this Garden-O-Matic website that I wrote a little while ago. So here I started with default source none because I was feeling ambitious and figured I should try this stuff out for myself. And then here are all the different kinds of resources and where they come from. You notice that I did use the unsafe inline keyword for style. So I have a style block that has stuff in it. You know, maybe that worries you, maybe it doesn't. Depends on how paranoid you are. You have the ability to control it, to turn it on or off as you choose. Yeah, you can see that I use fonts, fancy fonts. Everyone should use fancy fonts. So here's my cheat sheet that says what each of the directives maps to. So for example, media maps to both audio and video because they're closely related. Generally, it's not worth controlling them separately. And the sort of funny one is connect source. So connect source is like the grab bag of if you have a JavaScript API that loads resources. So like XML HTTP requests or WebSockets or workers or whatever, all that kind of stuff. Those are all controlled by connect source. Generally, those are not such a big deal, but if you want to control them, the option is there. It's at your choice. Okay, someone asked earlier, what happens if there's, oh, did you have a question? Chrome extensions do not allow you to have unsafe inline scripts. Yeah. If they did, then they would allow developers to open themselves up. So it's yeah. On the web, you have more choice. If you want to be a powerful extension in Chrome, we give you a little bit less choice because we're worried about you endangering users. So I mentioned that when your website violates a policy, there's an event that gets generated in the DOM that says this element tried to load something that violated your policy. We also, you can also specify a report URI. So there you give a URL, and then when there's a violation, the browser will send you this JSON blob to that URL and tell you something went wrong. So it'll tell you this document that was referred to by somebody trying to load this thing that was blocked because it violated this directive. And then here's the whole policy that was being enforced. And so the idea is that you can use this to see if you're causing trouble for your users. So you can get feedback about how well your policy is working. If there's some corner of your site that like maybe you don't have the policy quite right on, or maybe if you're being attacked, maybe the reports will give you some sort of early warning that there's an attack going on. And this feature is actually very popular. This feature is so popular that there's actually a report-only mode, which says, here's a policy, please just tell me reports about it. Don't bother blocking things yet. And so that's, you can also have both. You can have one that's enforced and one that's being in report-only mode. Yeah?
So that would be good if you want to set up a honeypot.
Yeah, so it's good for honeypots. It's also good for just testing. So suppose you were interested in CSP and you wanted to use it on your website, but you were afraid of breaking your website. Then you could try report-only mode for a while and then see how many reports you get. And then if that number gets low, then you could turn it on for real and you would sort of a softer deployment path. Okay, so this is my summary of Content Security Policy 1.0. So its goal is to mitigate cross-site scripting. It does that by whitelisting content, especially script. To use it, you have to do some work on your site. You can't just apply it as is. You have to really separate your code and your data so that the browser can tell where all the code is coming from. So that involves moving your inline scripts out of line, removing the inline event handlers, and ideally removing eval, but not really required. And you have default source if you really want to be secure by default and go the like paranoid lockdown route. You can get violation reports, which is feedback from the field about how well this is working. And this is, as I said, is implemented in Chrome, Firefox, and Safari. There's a partial implementation in Internet Explorer. They implement actually a directive that I haven't even told you about. Yeah. So I think what you're referring to is some people like the script tag, but they don't put script in it, they put data in it. And so they'll specify a type like type, this is my data, this is not script. And then the browser won't execute that script. It'll just leave it there in the DOM for something else to interact with. And that works fine. So here, because the script is not executing, it's not going to run afoul of any policy. It'll just show up, it'll be inline, it'll just sit there, it won't violate any policy, it'll just be fine. So I have a couple more minutes, so I'd like to briefly talk about the future of this stuff, which is Content Security Policy 1.1. So the biggest piece of feedback that we've gotten on 1.0 is that people wish they could use inline scripts. And this requirement of like getting all of your scripts out of line is like really, you know, it's work. Like it's doable, like definitely people have done it, but it's work. And so as an example, here's the Google Analytics snippet. They tell you to create this like GAQ object so that you can like call functions before it's loaded. It's like some fancy thing. But the point is, if you really want to do this the way it's meant to be done, you need to have this inline script. So how can we solve this problem? So the approach that we are experimenting with currently in 1.1 is to use a nonce. So if you're familiar with the idea of a nonce, it's just a random number that you made up one day. And every day you wake up, or every time your website is fetched, you make up a new random number. And the idea is that it's known to you, but unpredictable to an attacker. Does that make sense? So you can include in your policy that one of the places you can get scripts from is from people who know the nonce. And then this is just some like random number. I don't know how long it has to be. That's like up to you. You get to decide like how paranoid you are, how afraid you are of somebody guessing this random number you made up. Probably if it's this long, no one's gonna guess it. And then what do you?
The web protocol guys thought.
Yeah, well, make it longer.
Well,
Yeah, so what do you do with this nonce? Well, what you do is you take your inline script and you say, I know the nonce, here it is, and this thing matches this thing. And then, because the nonce is here, the browser can reason, oh, this must not be the attacker supplying this data, because the attacker doesn't know the nonce. So given that the nonce has been associated with this script, it's okay to execute, because that's what it, does that make sense? Yeah, so this is, this feature of 1.1 is like very popular. People are very excited about this. So there are also new directives in 1.1 that do various interesting things. So like before you could only control plugins by URL, and now you can control plugins by type. So you can say, I want to have PDF, or I want to have Flash, but I don't want Java or Skype or whatever it is you like or don't like. Yeah. Yeah, so that's a good question. So the question is, I'm not sure I 100% understood the question, but I think the question was, what is the scope of a policy? So when a site declares a policy, what does it affect? Does it affect an individual page? Does it affect the whole site? Was that your question?
Yeah, but like in 1.1, are you looking at trying to restrict it to a page or like something like an alarm notification proposal?
Yes. Okay, I understand the question now. So let me first answer the simple version, then I'll answer the advanced version of the question. So the simple version is the policy applies to a single document. So when you supply a policy with a HTTP response, it applies to the content in that response. And the advanced question is, maybe that's too coarse-grained. Maybe I wish that different parts of my page had a different policy. So that's a request that people have made, and we haven't figured out a good way of doing that yet. So if you have ideas for how you think we should do that, I would encourage you to come to the W3C working group and present your ideas and try to get people on board. Okay, yeah, so CSP 1.1 is under active development. If you're interested in this stuff and you want to share your experiences with 1.1 and tell us what we did well or poorly and what we should change in 1.1, this is the mailing list of the W3C. So it's the Web Application Security Working Group. We have a bunch of browser vendors there. We have a bunch of website operators there. We would love to hear more feedback. If you want to play with CSP 1.1 in Chrome, you can turn it on in the flags. So you turn on experimental blink features. Yeah, but if you want to use 1.1, that's stable and like ready for use in production. Thank you.